Thank you.
So good afternoon, everyone. So those who just introduced me, I briefly introduced the research title Assessing Road Expansions in Selected Zones Convoy Programs with Professor Ernst Segelschauer. So as Usko mentioned that roads were essential for connectivity and economic development and growth for every country, especially developing country for prosperity. However, that roads are leading to or causing to environmental degradation, especially in vulnerable ecosystem. So Gobi Desert is such an environment due to lack of soil nutrition and lack of accumulated precipitation. So our study area located Ulmo province, which is located in the southern side of Mongolia, and the total area is 15,100 square kilometers, and it's divided by four subdivisions, which is Nomon, Laivlu, Bayern, and Japland. And most of the precipitation occurs end of July or earlier of August. The highest month is end of the July and earlier of August as well. So our study main goals is we try to quantify to extend paved and unpaved road. Mostly how to it's growing or expanding to paved road by expanded, and also analyze vegetation response along two roads and compare effects of different roads of types, paved roads and dirt roads. So we created three types of plots for each type of roads. For example, 100 meter from paved road and 300 and 900. And also we created 100 created a plot from 100 meter from paved road, 300 and 900. So each plot size is 2,500 square meters. It's divided by 5 transections. So we collected biomass from each transaction and did LPI and also counted species richness. So here's the actual photo of that one of the plots. So we used 4 parameters: species richness of each plot and cover, and also that the gap of perennial plants and biomass. So we used the two-way ANOVA and the Jakarta's index. So here's that overall some center. There's that now it's a paved road, but in 2012 when we doing this research, it was a paved dirt road. You can say that the green that the plots also there's 100 meters from Mongolian border and the Chinese border between Ohti side. Oyutla is that copper mining located in Hamburg zone. Now I'm going to show that the results. Now you can see that the width of all of that, the size of extension of the roads. Some of them like 8 meters, but some of them 83 meters. So why is so different than this is size of matter? Because once people created their own track between the winter and all that herders, between winter camps and summer camps or spring camps, as you know, Mongolian herders live as an amateur. They move to 4 times per year is seasonally, but sometimes they created some center or private center. So once time they unusable that track, they use another one, created another one next to that old one, which is year after year, it's hard to expand the roads. Have you noticed that we went to that Hostel National Park Center, and the road is very bumpy, right? Because it's weird, the car can't go faster because there's a lot of that bump. It's a washboard. We call it a washboard. So once it's created, like some of the 800 wide, it's a road corridor. So people don't use unusable one track. They create another one. That's how it's year after year, bigger and getting bigger. So next slide, we'll see that very clearly look at in 2010. You see that all that track or pattern of that roads, right? But in 2000, after 5 years, you will see have to increase in that road tracks. Even in 2020, you will see that it's much bigger. So if you the road length multiple by width, the total area is very large amount. So you will see that we estimated all of that paved and the dirt road and gravel roads. So that total area is a very big area. Now so you can say that the first part is species richness. Sorry. And gray bar represents paved road, and the dark bar represents dirt road. However, within 100 meters, the paved road species richness is higher than paved road, dirt road within 100 meters, and also 300 meters, the paved road species richness is lower than dirt road. Also, that the shrub cover is higher cover in the both between all of the types of roads, paved road and dirt road, because shrub is the main plant of this dry area, and also that this is surprisingly, it's logically that the paved road less affected to the vegetation along to that annual fork and perennial grass and shrub. But our results show to us in other hand. For example, dirt road, there are more higher cover than 100 and 300 and 900 meters. And also the biomass showed to us that the paved road literally showed that higher literally with the 100 and 300, 900 meters. But the dirt road showed us much higher biomass. So we hypothesized also before we created the paved road that the road already close to all of the vegetation community belong to that paved road. So plant communities along to dirt roads exhibit higher species richness biomass in vegetation cover compared to those along paved roads. However, the widespread development of dirt roads and their associated corridors has significantly implied their negative ecological impact. Also, due to rapid decrease of vehicle ownership among the local residents, particularly heritage extent of dirt roads, their corridors is likely to continue expanding. Moreover, plant communities that were heavily disturbed during the construction of paved road have shown a natural recovery even after that the road became operational. So I'd like to show to us that the Japanese scientists reviewing the impact of the roads in Hinti province, Hilton in 2006. So see, if you see that the top line, it shows us just the natural vegetation of steppe. So maybe like more than 13 species over there. But here is that old track, but 15 years ago we used this old track, but not still using it. However, the species richness is 8, it's decreased. And even like 3 years, it's been used to last for 3 years, but it's still very less vegetation than three kind of species. Even this is not like indicators of state plants. It's like what is called weedy plants. You see that it's weedy plants more dominated than natural like Stipa Kirilovi or Agriconquistum or something. So this is the current trend that people using. Of course, there is no topsoil or organic matter or also no vegetation cover. It's so we can't imagine how long it's going to take forming fertilized soil. Maybe it's 100 years, maybe more than 1,000 years. You know, it's depends on the soil nutrition and the accumulated precipitation. Okay. Thank you for paying attention.
Thank you very much, Dr. Sanchimo. And of course,